The biological innovation I've designed is a new lumbar section for the spinal cord. A quick overview of the spinal cord shows us that it is a column of nerves that allows for communication between the brain and the body. The lumbar section is a section of the spinal cord which controls the lower body and voluntary muscle movements. It is very prone to injury. Syringomyelia is a disorder which affects approximately 40,000 Americans. Syringomyelia is when a cyst, or specifically called a syrinx, forms in the spinal cord. A cyst or syrinx is an abnormal sac that contains liquid. So, how does a syrinx form on the spinal cord? A syrinx forms on the spinal cord by the obstruction of cerebrospinal fluid in the central canal. The redirected spinal fluid then accumulates in the spinal cord to form a liquid-filled syrinx. As the syrinx expands, it compresses and injures nerve fibers, which leads to destruction of the spinal cord. Through the expansion of the syrinx, more and more spinal fluid buildup, the motor neurons in the lumbar section are damaged and killed. Even though it is possible to surgically remove the syrinx, the patient's motor abilities will not come back. Neurons do not divide. So once they are damaged or killed, the patient has lost them forever. Now let's take an in-depth view on the lumbar section replacement. In the example of the patient with the syrinx on their lumbar section, the patient is now paralyzed in their lower limbs as the syrinx has damaged and killed the majority of the motor neurons. In an effort to give the patient movement back in their lower limbs, I have designed a new lumbar section for the patient. The lumbar section will be composed out of the patient's own neurons, neurofibers, and tissues, so the new lumbar section will adapt with the body. Firstly, a CT scan will be performed to get imaging of the current lumbar section, as this will be required later on. To create the lumbar, first a lumbar puncture will be performed on the patient. A lumbar puncture or spinal tap is a procedure in which fluid is extracted from the patient's spinal cord. Healthy motor neurons from the spinal fluid will be removed and placed in a bioprinter to print the neural tissue in the shape of the lumbar section. The neural tissue will then be placed in glucose and water in an incubator to join together and grow. A biopsy of an intervertebral disc would also be done, as two would be removed during surgery and two new ones would be needed. The disc cells will also be placed in the bioprinter to produce two discs. During surgery, the patient will be given anesthetics to ensure that he or she will be unconscious. The intervertebral discs of L1 and L5 will be removed because from here the damaged lumbar section will be cut. Once the lumbar will be cut, the new one will be inserted into the vertebral column and the intervertebral discs will also be replaced. The patient will be monitored until the lumbar section adapts with the rest of the body. The patient would then be sent to physiotherapy to rehabilitate the effects of the syringomyelia. An ideal modification to this lumbar replacement will be to connect the new spinal cord section to the patient's memory. To tap the patient's memory of walking to the new lumbar section, it will give the patient the ability to walk right away. The biological innovation in the research and design of the recreated lumbar section can go just beyond the lumbar section. It can be used for the other section of the spinal cord and the spinal cord as a whole. Creating new sections of spinal cords could save millions of people's lives, of those who suffer from neurological and neuromuscular disorders, as well as diseases that affect the spinal cord. Millions of lives could be saved. Thank you for watching, and located beneath this video is a link to a quick 1-minute survey as well as contact information.